Hello, morning everyone. It's my pleasure to present here on the green solutions for the ships and ports. So first, I'd like to introduce myself. I take care of the infrastructure solutions for Hong Kong and Macau, which mostly covers metro, ports, and airports. And as you may know, okay, Schneider Electric is mostly focusing on the power distribution. Many people actually confuse us with Schindler, which is the famous manufacturer of the lifts and escalators. So around half the people I talk to actually confuse us and them. But anyway, for those in Hong Kong, you may have seen our advertisement because in the last few years, we do a lot of promotion about energy management. And actually, our core business is the power distribution. So as you see here on the left, we have the energy production, but Schneider doesn't do any energy production. And we also doesn't do the electrical appliances, which is on the right, the energy usage. But in between, we control and automate the process and make sure the power is distributed in a safe, reliable, efficient, and productive way. So, so we have various solutions on the different aspects. But today, I'm going to talk about the ports. So what's the problem? The problem is the air pollution in the ports. So of course, there are many different solutions. And fitting the Schneider scope, I'm going to talk about the OnShore Connection. So when the ship berth, like, okay, some of you may recognize this picture because this is last week. The Quantum of the Sea come to Hong Kong, which is great for us. Okay, but at the same time, they also have some emissions that we would like to reduce as well. So it's a huge ship. Okay, it's 20 megawatt, the biggest ever come. And actually, frankly speaking, I'm impressed with the Kai Tak terminal because it has lots of provisions and it can well take care of like 25 megawatts of cruise with the provision for the OnShore Connection. So I won't say too much about the equivalent emission, but it does a lot, and it is used to be a subject of protest in Hong Kong before, because you know we have a lot of environmentalists and people do care about the environment and our health. So I would like to introduce the OnShore Connection. Since I only got 15 minutes, so I won't go into any details, but just roughly, for ports, okay, there are two major energy users or electricity use emission sources. One is the crane on the container terminal, and the other is the ship when they berth that they need to turn on the auxiliary engine, and then all the emission will come from there. So, so the normal way, the usual way is like the crane, you do the electrification, which in Hong Kong, the major container terminals have are in the process of doing the change already. And what I'm going to talk about is a OnShore Connection, which plugs the vessel to the grid and use the power on the shore side rather than turning on the generator. So this essentially eliminates all the emissions from the ship, but of course, some people will argue that it transfers to the power plant. But anyway, the efficiency of the power plant is much higher than on the ship. So even with a coal-based power plant, the emission is much reduced overall. So the benefits, we have a lot of different solutions to take care of the pollutions in the ports. And for the OnShore Connection, I would say it greatly reduces both the SOx and the NOx at the same time, while some of the other approach, like the low sulfur fuel, will mostly reduce the SOx only. So this, of course, it fits quite well with the Macro 6 regulation, in which Hong Kong is one of the countries. So, and since last year, the IEC standard is finalized on the high voltage part of the OnShore Connection. we see a lot of countries actually put forward the project, and those got implemented in really short time. Because frankly speaking, this short connection technology has been around for like over 20 years. Okay, it first arises from the need to to berth the naval vessels, because they usually berth for like 6 months, 3 months. So it's very natural that they use the shore power rather than turning on the engines. So since a long time of evolvement, last year the standard is finalized, and then we see a lot of European countries has been adopting to this standard. And actually 2 years before, we don't have this much dots here. Okay, and this may show the trend, but it's not the whole picture, because these are all the Schneider footprints, and we don't do all the market. Okay, so, and of course I need to mention the big dots, which is in the US, and Port of Los Angeles is actually the leading port for short connection, as everyone knows. And it's good that we have a reference on how it is done, so that all the other ports, or even IEC standard, can refer to it. And we see a lot of new jobs in Asia, like Indonesia. When they build a new port, a container port, they do consider short connection, and it is implemented. So it's not completed yet, but it will be completed soon because of some civil delays. So just brief introduction on the short connection system. So you see on the right, you see the grid. So it's where the power is delivered from, and you see on the left is the ship. So in between are the scope for the short connection. And actually, for Schneider, we are good at the power distribution. And for the usually in the port, there will be a substation, an MV substation. So, but possibly it may not have enough power for the ship. Okay, because depending on the ship, if it's a container, it's only like 3 MVA or 5 MVA. It may not be difficult to squeeze those extra power. But for a cruise, like 20 MVA, it needs very good planning at the early stage. So it's mostly applicable to the greenfield projects. If it is retrofit, mostly it's too complicated or too costly to implement. Or due to some site constraints, it may not be possible at all. And of course, even if there's a well-considered project, there are some minor issues that may also impact the success of the project. Like we have also seen some, the site is planned, but sometimes the provision is not enough. And then maybe the cable trench may not be wide enough, or maybe the planned cable length is not enough, so it cannot really connect to the ship. So all these details need to be considered, but luckily with so many new ports going into short connection, the experience is building up in the industry. So I would say in the future, actually now, most of the players in the industry already knows quite well how such a project should be well implemented. And of course, even on the supply side, there may be some complexities. So for some sites which there are not enough power, so you may need to supply the power from 2 sources, from 2 different sources. And that will add a lot into the complexity in the system. But that can be done, and we have such designs before. So I would say that over the recent years, due to the vast number of projects in all over the world, the technology is reaching the mature state. And even with the various conditions on the ports, including the cruise or the container, it is not a difficult task for the industry to do it. But of course, for complicated sites, there is a cost impact and maybe a time impact as well. So on the implementation, on the equipment side, it's actually we use all the standard equipments. We just do the control and automation specific to this application. So the quality or the reliability is assured, and we guarantee the operability by following the standards from the IEC, which is a really, really well-defined standard. So for Schneider, with our experience in the OnShore Connection, we have actually standardized our product based on our experience in the many different occasions. So this is a container-based solution. We have all the equipment already installed in the container and connected and tested in the factory. So this will imply that there can be a very fast deployment in the site. Of course, the limitation is that the site need to have the area and space to host a container, right? And of course, this will reduce all the civil works. You don't need to build a room to house all the equipment and things like that. So it's more like a plug and play. Right. So this kind of standardization means that it's really mature for this technology, and you can have a really fast deployment. And for our experience, you can see that all over the world, there are different kind of ships and also ports that has been installed on with OnShore Connection. And of course, there are some really tough ones like the lower left. So the site here means that you need to take care of when the wave will come to the shore and come to the port. So you need to elevate the whole the whole structure. Okay, and there are some very stringent requirements because it is very humid and very subject to the corrosion from the sea. But all this has happened before, and we really believe that the technology is good enough right now. So a quick summary. Besides, actually, most of the infrastructure will be built in the ports, but for the ships, actually, the newer ships, like the ships built in these few years, will already have the OnShore Connection ready, okay, because that's the trend. And when you build a new ship, that's actually not much extra cost to you. But when you retrofit, the cost will really depend on how your ship is organized. Like I have visited some of the cruises before, and one of the cruises is built 15 years ago, and it has a so-called OnShore Connection equipment there. But of course, there's no standard before, and that OnShore Connection is actually for the connection to the dry dock, and doesn't really fit the IEC standard. So with the IEC standard, you can be sure that for both the shore and the ship, you can connect perfectly, just by following strictly the standard. So, and we also have partnerships with the shipyards, so that we can, for customers who want a ship's retrofit, we can have a full solution on evaluating the feasibility, ROI, and also align with the shipyard to do the retrofit for the customer. So for ships with enough space, like the door on the hull, and also the space for a few switchboard, which is not really big, actually this can be done in week, and some of the ships have been known to done on the fly when they move. Of course, you need the ship to agree to that, because that may incur some risk to the ship, but that has been done before. Okay, and of course for Schneider, we have a dedicated group for this, and we can do both the consultancy and also the full design and the implementation as well. And besides this, of course, we still have the energy management, which is our core solution for most infrastructures, and this applies to the port and the ship as well. So I think this wraps up my presentation on the OnShore Connection. If anyone wants to know some details, I'll be happy to explain more. Thank you.